Next example 2.10. In this question, we need to determine the magnitude and coordinate direction of the resultant force due to F1 and F2. First of all, we need to imagine it and able to imagine in 3D. As I said earlier, if 3D, we have three different plane, which is YZ plane, XY plane, and XZ plane. Now let's see the first plane. So we draw the parallel line. So this is parallel line to Z axis. Then we draw another line, this one and this one. Therefore, this one is belong to YZ plane. So another plane is belong to YZ plane. Let's have a look. Due to F1, we have this plane parallel to X-axis. We draw the parallel line. So this one parallel to Y. So this belongs to XY plane. Next, we need to simplify our drawing by sketch it. So as you can see here, we do have X, Y, Z axis and only the related forces. For example, for this one, we're going to do for F1 first. For F1, we need to resolve into Z axis. So we name that force as F1Z. So also we need to resolve our F1 into temporary axis. We call it as F prime. So this is temporary axis and the force for that one is F prime. For this one, you need to remember the trigonometry, also the SOHCAHTOA formula to find angle or forces. So now let's focus on resolving our F1. We need to resolve F1 to F1Z, also F prime. And the angle we know here is 35. So here is 35. Therefore, by using sine 35, we can get our F1Z. Don't forget the sign's negative because the Z-axis on negative side. So we get our F1Z is negative 143.4 Newton. Next, we need to find what is our F prime. So we have to resolve our F1 to get F prime. So to do that, we need to use cos 35 equal to F prime divide F1. Then we get our F prime, 250 times cos 35. So we get 204.8 Newton for our F prime. Then once we get our F prime, we need to resolve that into another axis, which is we have to resolve into X axis and Y axis. So we name it as F1X and F1Y. Because this F prime is because F prime initially belong to F1. To find the F1X, we need to use sine. So sine 25 is the opposite divide by hypotenuse. So we get our F1X is 86.6 Newton. Then we need to find our F1Y. For this one, we have to use cos 25. So by doing that, we get our F1Y is 185.6 Newton. That means we already resolved our F1 into X, Y, and Z axis. Then we need to write our F1 in 3D term, I, J, and K. For our I is 86.6 and our J is 185.6. Then for our K is negative 143.4. So we write that in 3D term. Then we need to resolve for F2. We know each angles, we know the force, then we can simply write into this form. We know our force is 400 Newton. We know our gamma is 120. Then our beta is 45, cos 45. Then our gamma is 60. So we get our F2 in 3D term. Once we get both forces in 3D term, we can find the resultant force, which is F1 plus F2. So we need to find what is the value on I, J, and K respectively. Check those value on I, 86.6 plus negative 200. Therefore, we get negative 113.4. Do the same for J and K component. So we get 468.4 for J and 56.6 for K. Once we have our force resultant in 3D notation, we simply can find our magnitude. So the magnitude for that is negative 113.4 power of 2 plus 468.4 power of 2 plus 56.6 power of 2 square root. Then we get the FR. The magnitude of our FR is 485.2 Newton. Next, we need to determine our direction for force resultant, alpha, beta, and gamma. Then for alpha is cos FRX negative 113.4 divided by force resultant magnitude, which is 485. So we get angle for alpha is 104 degree. Do the same for beta and gamma, and we get beta is 15.1 and gamma 83.3 degree.